Okay. In this section, I'm still continuing about the machine learning because this is the basic one. If you understand this one, you can directly go to the deep learning. You can go to the other learning approach that I will explain after the minutes exam. So in this section, I would like to explain about the distance method. What is distance method? So there are three things that I will explain. The first is the distance measurement. So we will learn some of the distance measurement. And on Monday, I will explain about the clustering. And on Thursday next week, I will explain about the clustering matrix into the class. Shock containment, Tangcumuk dengan clustering matrix. So the distance measurement. Why we need to have the distance measurement? First, I would like to explain the unsupervised learning. What we already learned until now is the supervised learning. What is supervised learning? Jido means that we have the class. What is the class? In the iris data set, the class is the flower type. For the advertising data set, what is the class? The class is the sales. For the golf data set, what is the class? The class is whether play golf or not. Okay. So you have what we call as the decision. So in your assignment, what is the class? In the orange assignment, the class is the tip. How much tip do you want? Okay. So every data that have class, we call it supervised learning. But the problem is, some data may not have class. You can get a lot of data in the world. You can get a lot of data from your smartphone. You can get a lot of data from internet. But many of those data have no class. So you can get the data from YouTube. You can get data from maybe neighbor. You can get data from dark. But most, I think all of the data have no class. So you need to understand the concept of unsupervised learning. In the unsupervised learning, no predefined classes. So there is no class. So it means we want to learn by observation. So we want to learn something only from the data. So it is different versus the learning by example. So you can see the class, or we call it supervised. So the typical application for this unsupervised is a kind of tool. So you can check the data distribution. So in Orange, we can use the tool to do the clustering or to do the unsupervised learning in order to get the insight. What is the data distribution? Or we can also use this unsupervised learning as the pre-processing step for other algorithms. So, for example, this one is example unsupervised learning. You have the data, just this one image, and you have another data like this image. You have this data, you have this data, and you have this data. But the problem is, we do not know what is this. If we know that this is a dot, okay, then we call this is supervised. If we know that this is a dot, okay, then we know that this is supervised. But we do not know. We don't have any label. Okay. Sometimes we do not say class. Sometimes we can say label. Label and unlabeled. If the data has label, so we call this is supervised learning. We can do supervised learning. But if the data is unlabeled, without label, then we call this is unsupervised learning. Okay. Now, with this data without label, how can we know? How can we know that this is dog? How can we know that this is cat? So we need to do something what we call as clustering. So clustering is the most popular way to do the unsupervised learning. In the unsupervised learning, or we call it the cluster analysis. So what is cluster analysis? It is to create cluster. So what is the meaning by cluster? Cluster is a collection of data objects. So data objects means one row, two rows, three rows, four rows. So this is one object. This is object number one. This is object number two. This is object number three. This is object number four. And we want to know the similar object. If they are similar to one another, then let's make it in a group. So if they are similar, let's make it in one group. This similar means unrelated. So if the data is not related to the objects, and put it in another group. So the red color, because they are related, so they can be in one group. But this one is not related with the red color, so it is in different group. Okay. So the cluster analysis means sometimes we call it clustering, or sometimes we call it data segmentation. So finding similarities between the data according to the characteristics found in the data, and grouping similar data objects into clusters. So we want to find what is the similarity between this data and this data. We want to find the similarity between this data and this data. We want to find the similarities between this data and this data. And then we want to find the similarities also from this data and this data. So we want to measure all the similarities. And if they are similar, okay, we put here. If they are not similar, then we put in different groups. The flow of the unsupervised learning is similar with the supervised learning. So you need to do the exploratory data analysis. So you need to check the statistics, you can do the data visualization, and then you need to do also the data preprocessing. So you learn about the data cleaning. But before we do the machine learning, we need to do one more thing. It is similarity measure. Or sometimes we call it also distance measure. Okay. So those two things are related. Some people they want to use the similarity measure. Some people they want to use distance measure. Now for this class, I will just use distance measure to explain some of the methods. For example, I have data. And this data without labels. So this data without class. So data in the database exists without any labels. So can you guess what is this data? We have phone ID. Okay, this is ID1, ID2, ID3, ID4. Okay, maybe we have 10 phone, smartphone. Battery. Okay, so this is on the explanation. This is hours of battery last. Okay, so this is the phone number can last for 12 hours. And then the camera means the camera pixels. So maybe this is 4. Camera is 4 megapixel. But what does it mean? This data? It's not clear. We have only the data about battery and camera. The phone number 2. The phone number 2. The battery can last for 26 hours. And the camera is 16 megapixels. The phone number 3, the battery can last for 9 hours. And the camera is 9 megapixels. Okay, maybe this is a second-hand handphone. Jungkook and okay, let's say if I have this second-hand handphone, how much money that I can sell to other people? Maybe that can be one option. Or maybe I can say that based on this data, can I distinguish the phone which is high quality phone and low quality? Or maybe from this one, I can distinguish new version and old version. So everything can be done with this data because this data has no limit. So the first easiest way to analyze this data is to check the plot. So we can do the visualization. So we need to use the distance measure. We can measure the possible clusters based on the distance. And the cluster is assigned as the link. So for example, okay, I just want to say that this data, I want to make it into two groups. Okay. So if you plot the data, you can have this one. This is the data number 1. This is the data number 2. Okay. This is alright. Okay, so this is the battery, and this is the camera. So we can plot if the battery is 12 and the camera is 4 megapixel. So this is the location. And then number 2, 26 for the battery. This is the hours. Maybe here. Okay. And then 60 for the camera. Okay. And so on. Then we can check. Okay. The blue color, they are in one group. And this one, they are in one group. Then I can say the data which is number 1, number 8, number 6, number 4, number 3, they can be in one group because they are similar. They have somehow similar on the battery and also the camera. Then I can put another column, or I can put a new column because this is the little space on the group. The cluster one is from the data number 1. the data number 3 is cluster 1, cluster 1, cluster 1, cluster 1. And cluster 2 is the data number 2, number 9, 7, 10, and 5. So based on the data characteristics, I can make two groups. My question is, can I create 3 groups? Yes, of course. We can. Can I create 4 groups? Maybe possible, but the result might not be so good compared to 2. Can I create 5 groups? Maybe it's not compared to 2 groups. Okay. Then how to know what is the best one? The best one is 2 or 3 or 4 or 6 or 7 and so on. So we need to have the distance measure. Okay. The first distance measure is Manhattan distance. So you learned already about the Manhattan distance. When you learn the MAE, you still remember? When we learn about the regression, when we learn about regression, there is performance measurement, and those performance measurement we have MAE, MSE, RMSE, mapping. In order to calculate the MAE, we use this Manhattan distance. So Manhattan distance, or people say it is a city block, or sometimes we call it L1 no. It is only the subtraction between the data. This is absolute. So the data can be measured just by subtraction of the first and the second. First and the second. And so on until the attributes number. There is another kind of Manhattan distance. We call it Hamming distance. It is the number of bits that are different between the 2 binary factors. So I will not explain the Hamming distance. Let's just focus on the Manhattan distance. Euclidean distance. In the Euclidean distance, or sometimes we call it L2, it is the difference between the data, and then we do the square cube plus the difference between the data, and then we do the square, and so on, and then we will do the square. Yeah, you can do in orange like this one. In orange, you can see there are many kind of distance measured. So you can look at the Euclidean normalized, and Manhattan normalized, and there are many other distance measurements such as mass, Hamming, cosine, Persson, Spearman, and Chow. Okay, so we will learn on the Euclidean, Manhattan, cosine, and Chow. Now, how to use the Manhattan distance and how to use the Euclidean distance? Let's see this example. I have 10 phones, and then I have the battery and the camera. Now I want to see the distance between the phone number one and the phone number two. What is it? So I need to check the distance between
this one
and
and
this one.
this one.
So the
distance number between the phone number 1 and number 2 is
12
minus
minus
26.
12
minus 26. And then we put
the
the
absolute
plus
plus 4
minus 16. We put absolute.
So the
So
result
the
will be
result will be
14
plus 12
and
and
it is
it is
26.
26.
So the
So
26
26,
this is
this
the
is the
value
value
to show
to
that
show that this is the distance between
1
1
and
and
2. Now let's see
now let's see the distance between 5
and
and
7.
7.
The
The distance between 5
and
and
7.
7.
Then it
Then
means
it means
22
minus
minus 24
24.
and we
And
put
we
the
put the
absolute
absolute
plus
plus
12
12
minus
minus
15.
15.
So we put
So we
also
put also
the absolute.
the absolute.
Then
Then
this
this
is 2
is 2
plus
plus 3.
So the
So the
distance
distance
between
between
5
5
and 7
and 7
is
is
5.
5.
Then we
Then
put
we put
here.
here.
Okay.
Okay.
So you can
So
see
you can see
all
all
the
the
distance.
distance. Okay.
So using
So
the
using the
Manhattan
Manhattan distance,
can
I
have-
can have
because
this is the distance
matrix.
matrix.
This is
This is the distance from
data
data
number 1
number 1
and data
and
number
data number 2.
This is the
This is the distance from data number 1 and number 3.
This is the
This is the
distance
distance from data number 1 and
number 4.
number 4.
This is the
This is
data
the data from this
data number
data
1
number 1 and
number
number
and so on.
and so on.
What about
Euclidean distance?
So the
Euclidean
Euclidean distance.
distance.
Let's say
Let's say
I
I want to show the distance between 1 and 2.
then
Okay.
12
12
and
and
26.
26.
12
12
minus
minus 26.
We want
We want
to
to do the
square.
square.
0.
0.
Plus
Plus 4
minus
minus
16.
16.
4 minus
4
16.
minus 16.
We also do
Also do
the
the square.
So we
So
will
we will
do
do the
summation
summation.
and
And
this is
this
14.
is 14.
14
14
square
square
plus
plus
12 square.
12 square.
So the
So
result
the result
will be
will be
rooted.
rooted. Okay, so
Root here.
here.
After we got
After we got
the
the
result,
result 196 plus 144,
we will
we will root it.
after we
After
do
we
the
do
root,
the root, then we will get the value like
18.439.
18.439.
So this
So
is
this is the distance between the data
number
number
1
1
and
and
number 2.
number 2.
So you can
So
also
you can also
measure
measure the data number 1 and number 3, data number 1 and 4, data number 1 and 5, data number 1, 3, 6, and 7.
Okay.
Okay.
What about
What about the distance between 5 and 7?
the distance
The
between
distance between 5 and 7.
So the
So the same with the previous one, 5 and 7.
So 22
minus
minus
24 plus
12
minus 15.
So we
So
do the
we do the
square,
square,
and
and after that
we
we
will
will
do the
the
summation,
summation and we do the
square.
square.
The result
The result is
3.606.
3.606. So this is
the
the distance between data 5 and 7.
Now,
Now,
my question
is
data
distance
from
from
1,
1, 2
is it
is it
equal
equal with the distance from 2, 1?
Is it the
Is
same
it the same
or not the
or
same?
not the same?
Distance between data
Between data
1
1 and 2
and
and
distance
distance between data 2 and 1.
same
Same
or not
or
same?
not same?
Same.
Same.
Okay.
Okay.
So
So
this
this is
the same.
the same.
You can
So
see
you
here
can see here
the
the
data
data
2
2
and 1
and 1 is the same with the data 1 and 2.
So sometimes
Sometimes
we
we just need to have only
one
one
triangle.
triangle.
We call it
Because this is the
triangle matrix.
matrix.
We can
We
use
can
the
use the triangle below,
or we
or
can
we
use
can
the
use the
triangle
triangle
on the
on the
upper side.
upper side.
It's the same.
The same.
The same
The
also
same
with
also
the
with the Euclidean distance.
The
The
triangle
triangle
below
below
and the
and the triangle
at the upper
at
side.
the upper side.
So they are
So they are
the same.
the same.
Okay. In
In
orange,
orange,
so
so this is the result from orange.
It
It
is
is
clear
clear
with
with the color.
when you
You have the color, means that
when the
when
color
the color
is
is
green,
green,
the
the
distance is
reason is
high.
high.
When the
When
color
the color
is
is
light
most
green,
green,
the
the
distance is
distance is
small.
small.
So we
So we can say something
that
that
from the
from
data
the data
from
from
this
this
distance,
distance,
which
which one
is
is
similar
similar
with
with
data number
data
one.
number one.
Data number
Data
one
number
is
one
similar
is similar to
data number
data
three,
number three,
data number
data
four,
number four,
data number
data number
six,
6,
and
and
data number
data number 8.
What about
What
data
about
number
data
two?
number 2?
Data number
Data number 2
is
is
similar
similar
to
to the
data number
data
five,
number 5,
data number
data
seven,
number 7,
data
data
number
number
nine,
9,
and
and
data
data
number.
number.
So let's say
Say
if
if we have the values, which is, for example, the distance is
10. Okay. So the distance
which
is
is
lower
lower than 10 is similar, and the distance which is higher than 10 is
this.
similar or not related.
So
So
this
this
is
is also the same result with this one.
Okay. So you
So
can
you can see
this
this
cluster
cluster
also can be used
based on the distance.
Then
Then,
yeah,
yeah,
you can
you
see
can see
that
that using the Manhattan distance,
we
we
can
can
look
look
at
at
this
this
cluster
cluster
and
and
this
this
cluster.
cluster.
So there
So
are
there
two
are two
ways.
ways.
And
And first, you can use the visualization,
Okay. And the
and
other
the other
you can use
the
distance
distance method.
But if
But
you
if you use the visualization,
it
it
is
is
very
very
subjective.
subjective.
But if
But
you use
the
distance
distance measure, it is more
objective,
objective.
you have the value. There is another kind of measurement,
we call it cosine similarity.
The cosine
Cosine
similarity
similarity is a measure of similarity between two
non-zero
zero factors.
non-zero
Zero
factors.
factors. It means
We have
we have factor,
But
but
the
the
value
value
will
will
be
be
some
positive.
positive. Let's say
Let's
if
say if we have zero and
there's
there's
another
another value with 5, maybe
one,
1, 2, and so on.
defined
Defined
in
in an inner product space. Inner product space. So we have a space that we need to define the value.
So the
So
data
the
format
in the vector of maybe document
or
or
maybe
maybe
the other
the
kind
other
of objects, etc.
etc.
So the similarity
Similarity
values
values will
be
be
using
using
this
this
formula.
formula.
So this
So this
formula
formula
is
is
the
the
cost
cost
of
of theta. Okay.
so
So cos,
this is
this is
cosine
cosinus
between
between item 1 and
item.
item 2.
We call it
Because
this is
this is A
and B.
B.
So
So A is the item 1 and B is the item 2.
So
A
product
product
B
B
divided
divided by
the
the distance between
the
the
items
items in A
and
and the distance
between only the value
in B.
or we
Or
can
we can
have
have
the
the
formula
formula something like this.
Okay, so
Okay,
this
so
is
this is the square root of
A
A
squared and the square root of
the sigma
B
B
squared.
squared.
And
And
then
then
this
this
is
is the A multiplied by B
it is the summation.
summation.
Now
Now
let's see
how we can do this one.
So for
So for
example,
example,
this
this
is
is a text document. So
after the
after
meeting,
this, I will explain about facts
and
and NLP, the natural language processing.
I
I
have
have
facts
facts
like
like
this
this
one.
one.
In
In
hockey,
hockey,
the
the
team's
team's
consistent
consistent effort leads to win.
while in
In
soccer,
soccer,
teamwork
teamwork
plays
plays
a
a
crucial
crucial
role
role
in
in
achieving
achieving
a
a
win.
win.
All
All
their
their
dedication,
dedication,
blah, blah,
blah,
blah,
blah,
blah,
blah,
blah.
blah. Okay.
Now, I
Now, I
want
want
to
to calculate
the
the
important
important
keywords
keywords
in this
in this
document.
document.
So the
So the
important
important
keywords,
keywords, I will put it into the column.
So let's
So
say this
this
is
is
document
document
one.
one. Okay. This is document one.
So I
So I
can
can
measure,
measure,
okay,
okay, how many in the word
team.
team?
Okay,
Okay, so maybe this is
one,
one,
two,
two. Okay, we got the teamwork.
three,
Three,
four,
four, five.
okay,
Okay,
then
then
the
the
team
team, there are five.
and so on.
And
So
so
we
we
also
also calculate the forward, we also calculate the hockey. Okay,
Maybe this
this
is
is
only
only
one.
one.
Okay,
Okay, then two.
maybe this
This
is
is so.
where
What
is
is?
okay,
Okay,
there are
two.
two.
Maybe this is wrong. Okay,
So let's say
let's say we have three,
and then
and then we have super two.
we have
We have
win
win
two.
two.
The other
The
is
other is
zero.
zero, 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 zero.
Now
Now
I
I
want
want
to
to check also document number two.
So let's
So
suppose
suppose
document
document number two,
we have
we have
this.
this data.
So what
So
you call
what
this
this
is
is factor.
we have
We
the
have the
values.
values. How many
words
words
are
are available in the document one for the word team?
How
How
many
many
words
words
are
are
there
there
in
in the document one about the word quotes?
and
And so on.
so we
We
need
need
to
to
find
find the similarity.
What
What is the similarity between document one and two?
Then
We can extract the data.
In
In
document
document
one,
one, we have
this
this
factor.
factor.
5,
5,
0,
0,
3,
3,
0,
0,
2,
2,
0,
0,
0,
0,
2,
2,
0,
0,
0.
0.
And
Then
this is
this is the document one.
What about
What about
document
document two?
We have
We have
3,
3, 0, 2, 0, 1, 1, 0, 1, 0, 1.
So
So
this
this
is
is
well. Now
now I
I
want to know
the
the
distance
distance between document one and document two.
So the
So the
first
first
is
is
to
to
do
do
the
the
product.
product.
The
The
product
product
means
means we
want
want to multiply 5 multiplied by 3.
Okay.
5
5
multiplied by 3
plus
plus
0
0
multiplied by
multiplied by
0.
0.
5
5
multiplied by 3
plus
plus 0
0
multiplied by
multiplied by
0
0
plus
plus
3
3
multiplied by
multiplied by 2
plus
plus
0
0
multiplied by
multiplied by
0
0
plus
plus
2
2
multiplied
multiplied by
by
1
1
plus 0
0
multiplied by
by
1 and so on
until the last data.
data.
And we
And we
can
can
get
get the value that
the
the
summation
summation
of
of this one equals to 25.
Now
Now we will check also the T1
to
to
factorize
factorize
of
the document.
to factorize
Factorize
of the document
document
one
one
means
we will do the calculation only on this particular document.
So we
So
will
we will
do
do the 5 square
plus
plus
0
0
square
square
plus
plus
3
3
square
square
plus
plus
0
0
square
square
plus
plus
2
2
square
square
and
and so on
until
till
the
the
last
last one,
until
until
0.
0 square.
And then
And then we
do
do the power 0.5.
do you know
What is
power
0.5?
x
X
power
power
0.5.
0.5.
What is it?
What is it?
It is
It is
the
the
square root
square root
of
of
x.
x.
Okay. Then
And
we
we
have
have
the
the
42
42
square root
square
of
root of
42.
42,
Then
and
this
this
is
is the result.
6.4.
What
What about
about
the
the
determinant
determinant
2?
2?
So the
The
determinant
determinant
2,
2,
we have also
also
this
this
value.
value.
3
3
multiplied by 3
3
or
or
3
3
power
power
of 2.
of 2.
0
0
power
power of 2.
2
2
power
power
of
of
2
2
and so on until the last value, which is 1 or 2. And you can get the value 16. And again, it is powered by 0.5. And it is same with the square root of 1. So we have the square root of 17. This is 4.1. So based on the result, based on this formula, so this is the summation of A and B divided by the square root of A square multiplied by the square root of B square. And we can get this is the result of 25 divided by 6.481 multiplied by point. So the cosine similarity shows that 0.94. Okay. The similarity, if it is 0.94, it is good or bad. Zero point 94, because it is similarity, you can have two analogs. It is high similar or low similar. If you look at this, it is high or low. This shows high similarity. The value, if it is higher or nearby one, it is high similarity. So you can see from here. Okay, there's a high similarity between the word T. There's also a high similarity between the word T. And also there's a high similarity between the word soccer. And there's a high similarity between the word win. So we can say that those two documents is highly similar. If the low similar means the value is closer to 0. So high similar, the value is closer to 1. So using this data, I can say that document 1 and document 2 is highly similar. What about if the value is 0.6? Not that similar. Okay, good. How about if it is 0.14? It is similar. Okay. A value getting closer to 0, it is not similar. Okay. The other thing about the similarity, you can use similarity. So in Jakarta similarity means we want to compute something related to the categorical data. So Jakarta is mostly used for the categorical data. What about this one? So let's say I have 3 users. So I have 3 users data. So the user one, he has used 3 items. User one has used 3 items. User one has 5 items. User one has glasses, 3 items, but no jacket and one belt. User 2, this is the data, and user 3, this is the data. So when we do with the Jakarta similarity, usually we will treat this matrix as Boolean. You know Boolean? This is true or false. So in the programming, we call it Boolean, true or false. in the
data categorical, we usually say this is kind of binary.
So that's why
That's
we
why
have,
we have what we call as the Boolean matrix.
and in Boolean
Boolean
matrix,
matrix,
we just set this
this
is
is
zero,
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 and one.
So
So
if the
if the
person
person
has
has
to
to
choose,
choose,
okay,
okay,
we can
we can say one.
So
So
if
if
the
the
item
item
is
is
higher
higher
than
than
zero,
zero,
it is
it
one.
is one.
If
If
there
there
is
is
no
no
item,
item,
this
this
is
is
zero.
zero.
If the
If the
person,
person,
let's
say
say user
user
2,
two,
he
he
has no
has no
shoes.
shoes,
Okay,
okay, then this is
zero.
zero.
The
The
person
person
has
has shoes,
has what?
words.
This
This
is
is
one.
one. This is
So
so
regardless
regardless
of
the number,
we
we
just
just
want
want to know that
the
the
person
person
has the
has the
item.
item.
One,
One,
it means
means
the person
person has the item.
zero
Zero
means
means
the
the
person
person
has
has
no
no
item.
item.
Now,
Now,
I
I
want
want
to
to know
with
is
the
the
Jakarta
similarity.
similarity. With the
With the
Jakarta
Jakarta
similarity.
similarity.
So how can I know the similarity between user 1 and user 2?
two?
So with
So
the
with the
Jakarta
Jakarta
similarity,
similarity, I know that
user 1 has
has
shoes,
shoes,
but
but
user
user
2 has
has
no
no
shoes.
shoes.
User 1 has
Has
shirt.
shirt. User two
has
has
shirt.
shirt.
User
User
1
one
has
has
watch.
watch.
User
User
2
two
has
has watch.
So the
The
user
user
1
one
has
has
glass.
glass.
The
The
user
user
2
two
has
has
no
no glass.
jacket.
Jacket.
No
No
jacket
jacket in the user one.
User 2 has
has
jacket.
jacket.
And
And
both
both
of
of
them
them
they
they
have.
have.
So
So
the
the formula
will be,
would be
we want to check
the
the
intersection.
intersection means
Means
how many
items
items
they are similar.
in this
In this
case
case, we have
shirt
here
and
and
watch
watch
and
and
belt.
health.
In this
These
items,
items,
they
they
both of them
have the items.
then
Then
we
we
call
call this is three.
three items they have. And
And
the
the
union
union
means
means
how many items
items
that
that
they
they
share
share
and at
at
least
least
one
one
of
of
them
them exists.
So
So
here
here,
one of
one
them
of them exists.
one
One of them exists, and one of them exists.
So we have six items in
in
total.
total.
So
So
three among six items
items,
they
they
are
are
similar.
similar.
So the
So
similarity
similarity
between
between
user
user 1 and user 2 is
zero.
0.5.
1.3
divided by 6.
Now let's see
What about the distance between
user
user 2 and
user
user 3?
user
User 2.
User 2 has no
no
shoes.
shoes. User 3 has
Shirt
shirt
is
is 1 and 1.
User
User 1,
User
user
2
2 has
watch
watch, and user 3 has no watch.
User 2
User
has
2 has jacket, user 3 has jacket, and user
2 has belt
belt,
and
and
user
user 3 has belt.
Now
Now,
we don't
we
need
don't
to
need to
consider
consider this one.
why? Because
Because
both of
both
them
of them different.
So
So
the
the union means
when the two
two
users
users
they
they
share
share
item or
or
at
at
least
least
one
one
item,
item they have.
but
But
if
if
both
both
items
items
they
they
don't
don't
have
have
it,
it,
then
then
we will not consider it.
consider it.
So the
So the
Jakarta
Jakarta
similarity
similarity between the user
2
2 and user 3 is
2.
2.
2 it means
Means
two
two
items
items.
they have same or this is the intersection and
And
five items are in the
the
at
at
least
least
one
one of them
they have. And what about the user
user
1
1
and
and user 3?
user
User
1
1 and user 3.
So we have 2 divided by
divided by
6.
6.
This item,
Okay,
they
they
are
are
available. This item, they
they
are
are
available.
available.
This item, only one of them,
Only one of them. Only one of them. And
only one of them.
one of them.
So
So
two of them, they
they
share
share
the
the
same
same
items.
items.
Among
Among
six
six
items,
items
that
that
one
one
of them
of them
they
they
have.
have.
Okay. So
So this is how to measure the Chakra similarity.
Okay, so I
I think that's all for today for the distance measure.
If you
If
know
you know
the
the
distance
distance
measure,
measure,
we
we
will
will
learn
learn
how
how
to
to
deal
deal
with
with
the
the
KPIs
KPIs
and
and
how to
to
deal
deal
with
with
the
the clustering performance.
Okay. And
And